Using a phone's microphone, you can find the initial height of an object being dropped using the times in between each bounce of the object. The phone measures the length of time between each bounce, recorded as delta t, and, neglecting air resistance, uses these delta t values in a modified free-fall equation known as h equals 1/2 times g times delta t over 2 squared to find the heights after the first two bounces. The potential energy in the object only changes due to varying maximum heights after each bounce. Therefore, if we assume the ratio of lost energy is the same as the first bounce, we can approximate an initial height using the equation h0 equals h1 times e0 over e1, where h0 is our initial height, h1 is the maximum height after the first bounce, and e0 and e1 are the potential energies of the initial height and the maximum height after the first bounce, respectively. The app VFox listens for the bounces and performs the calculations real time, resulting in your initial height. The first thing that needs to be done before beginning the experiment is to adjust your threshold so background and environmental noises don't trigger the recorder prematurely. Once this is done, begin the experiment. The ball was dropped from an initial height of approximately 100 centimeters. The experiment was then repeated from a height of approximately 150 centimeters, as well as with a height of approximately 200 centimeters. Many factors contribute to the errors shown above. Things like environmental and ambient noise contribute noise pollution which, if not properly adjusted via the threshold settings, can throw off the app's calculations slightly. Human errors, such as moving your hand slightly before dropping or letting the ball touch other surfaces before it reaches the floor, also contribute to the errors, as these examples decrease or increase the time it takes for the object to hit the floor, respectively.